Hello, viewers. Today we'll be talking about text summarization, its history, types, and how it is done. With the evolution of the digital world and its impact on various industries, dedicating time to sincerely read an article, document, or a book to decide its relevance is no longer a feasible option, especially considering the time scarcity. Summarization finds application in media monitoring, newsletters, contract analysis, question answering bots, and even in this video script. Let us talk briefly about the history of summarization. Initially, if then rules and encyclopedia knowledge were used to determine the scoring of various pieces of text in the passage. Moving on, the idea of relatedness came up. The methods such as TF-IDF were used to determine the importance based on the frequency of terms in the sentences and documents, along with other features like sentence length cutoff, fixed phrase, paragraph feature, thematic words, and uppercase words. Further, neural networks gained significance as they were used to generalize the main features of the text. Other parallel developments included diversity-based clustering and graph-based algorithms. Text summarization using the sequence-to-sequence model in 2016, where an attentional encoder-decoder recurrent neural network, which was actually established for machine translation, outperformed many other models. Currently, the state-of-the-art transform architecture uses sequential transfer learning, which includes two stages. First, a pre-training stage where a neural network is trained on huge amounts of general data, and then a fine-tuning stage where the model is trained on domain-specific tasks such as text classification, question answering, or summarization. There are two types of summarization processes. In extraction-based summarization, a subset of words that represent the most important points is pulled from a piece of text and combined to make a summary. Think of it as a highlighter that selects the main information from a source text. As we can see here, important pieces of the original text are highlighted in the summary. In abstraction-based summarization, advanced deep learning techniques are applied to paraphrase and shorten the original document, just like humans do. Think of it as a pen that produces novel sentences that may not be a part of the source document. Here, we have almost a new summary with the same understanding as that of the original text. Let us go through a general extractive summarization process. Initially, pre-processing is done, which includes methods such as removing stop words, punctuations, special symbols, reducing the words to their roots, tokenization. This is done to have a non-redundant, meaningful text document. The next step is to get features from the previous text, which are simply numerical representations of the text. These features may be, for instance, word frequency counters, number of sentences, sentence length, title words, or phrases. In the last part, we use the above mentioned features to find the weight of each sentence, which is calculated using a desired machine learning or deep learning model based upon the text. These techniques use appropriate features that are chosen to create a training model. The trained model is then used for classification to determine whether to include a sentence in a summary or not. The techniques that can be used are CNN, ANN, or for these systems. In sentence similarity, we eliminate duplicate sentences using the sentence similarity module. We estimate the degree of similarity between a set of different text files. A threshold value is calculated to determine the maximum allowable similarity, which is used as the basis on which sentences are picked from the main document to generate the summary. Moving on to the abstractive summarization, we have an original document which is passed through something called an encoder. An encoder could be a simple neural network, a sequence to sequence RNN, or a transformer encoder. The encoder generates an embedding, which is nothing but a numerical representation of the text in the original document. This numerical representation or embedding can be contextual as well as non contextual. Once we have the embedding, it is passed through a decoder, which works as a language model where we can give certain input and it tries to predict the next word in the sequence. Through a series of these production, we are able to generate a summary draft. The summary draft can further be refined in a stage where we can control what amount of originality and what amount of novelty do we want in our new summary. We can also include some contextual information here. A final summary is generated which not only contains novelty in style, but also retains the semantics of the original document.